Automotive engineers have been searching for years for improved power plants. Ford Motor Company engineers have developed a turbine engine that combines the simplicity of the turbine with the durability and economy required for conventional long-haul truck engines. Turbine-powered trucks like this one have been handling routine Ford fleet duties since summer of 1968. The turbine, compared to conventional engines, is much simpler in design. It's based on compressors and turbines spinning at very high speeds, up to 37,000 revolutions per minute. Ford engineers expect that fuel consumption and maintenance costs will be fully competitive with comparable diesel engines. The only obvious appearance feature of these trucks is the exceptionally large exhaust stacks, since turbine engines require a much larger volume of air than piston engines. Today's truck engines must give the driver the ability to accelerate comfortably into expressway traffic. Actual highway operation provides a far better test than even the most elaborate test track or proving grounds. Engines are designed for long hauls on the interstate highway system of the 1970s. They're so quiet that the driver can enjoy his radio without the roar and vibration typical of reciprocating engines. Drivers find that these prototype trucks run with high-speed traffic on expressways with ease. Once Ford truck drivers assigned to the fleet become acquainted with these experimental units, they soon found them preferable to the usual diesel-powered jobs. Supervisors assigned drivers on a rotating basis to give all of them an equal chance behind the wheel. And the truckers attracted a lot of attention from fellow drivers anytime they stopped for a cup of coffee along the way. For these are the first turbine trucks in service in the world. Like a man who brings his new car home to show it off to his family and neighbors, Hugh proudly answers questions about his new baby to his fellow drivers. After tipping the cab forward, he points out the combustor, conventional truck accessories, the regenerating housing, and one of the exhaust ports. Other men in a Ford conference room in Dearborn were also briefed on the engine. More than 60 interested groups have visited the engineers who developed the 707 engine to learn about its capabilities. Guests have included engineers from leading U.S. companies who want low cost and better power sources for trucks, buses, and industrial applications. A key component is the regenerator, a disc of ceramic material with 1,000 tiny openings per square inch to transfer heat efficiently. The engine itself is about 10% smaller and 30 to 50% lighter than diesels with similar power. This power turbine and gearbox assembly converts the high-velocity thrust of air into usable power. Variable nozzles control the 375 horsepower output. Combustion takes place inside this small combustor can. A single fuel nozzle and single igniter attest to the simplicity of design. The roaring flame, source of all the power, happens here. Back on the highway, Hugh returns his rig to home base. Another trip completed. Another turbine test accomplished.